Okay, in this video, equations with linear relationships. So in our last video, we looked at whether a relationship was linear or not. Now we're going to look at, once I know it is a linear relationship, how can I evaluate these based on a situation, an equation, a table, and a graph. So in our first example, we have an equation, y equals x minus 5. So now I'm going to plug that information into my table so that I can get some ordered pairs in order to graph. So what I'm going to do first is write my equation right here. Now, the first thing I want to do is I want to plug in some numbers. I want to plug in a number for x and then a number for y, and then see what those ordered pairs would be on my graph. So let's say I say x is 0. So for x here, I'm going to replace that with 0. So 0 minus 5 is negative 5. So my y over here is going to be equal to negative 5. Now maybe let's plug in 1. So y equals 1 minus 5. 1 minus 5 is negative 4. So y is going to be equal to negative 4. Now let's try 2. So I have y equals 2 minus 5. 2 minus 5, negative 3. Let's try one more. Let's try 3. So y equals, again, I'm plugging in this x value in for the x in my equation. And I get negative 2. So now I have ordered pairs. So my ordered pairs that I'm going to graph are 0, negative 5. And again, to graph, the x tells me how many to go over on my x-axis, and the y value tells me how far up or down on my y-axis I need to go. So I'm going to start at my origin. My first ordered pair is 0, negative 5. So that means to go over nothing, but down negative 5. And these are counting by 2s. So 2, 4, and in between here for 5. The next pair of ordered pairs is 1, negative 4. So I'm going to go over to 1 and down to negative 4. The next one is 2, negative 3. Over 2, down to negative 3. And then the last one that I found out was 3, negative 2. And I can see, if I draw this straight as I can anyway, this is going to be linear because it's in a straight line. All right, now let's look at an equation. It says Ben is saving money for a new laptop. He already has $50 in his account that his grandmother gave him for his birthday. Now he plans on saving $25 per week. This is crucial information here. The per week tells me it's going to have a variable next to it because I don't know how many weeks it is. So now I'm going to write my equation. Y equals $25 per week. So that X is per week. But he also had $50 already in his account. So plus 50. Now we're going to go over here and do the same thing that we did on the first one. I'm going to start plugging in some numbers. So let's try 0. So let's plug in. I have 25 times 0 plus 50. So 25 times 0 is 0 because anything times 0 is 0, plus 50 is 50. So that gives me that y value. Okay, now let's try 1. So I have 25 times 1 plus 50. 25 times 1 is 25, plus the 50 is 75. Now let's do 2. 25 times 2 plus 50. 25 times 2 is 50, plus 50 is 100. And let's do one more. Let's try 3. So I have 25 times 3 plus 50. 25 times 3 is 75, plus 50 is 125. Now I have my ordered pairs, 0, 50, 175, 2, 100, and 3, 125. Now I can graph. So first ordered pair was 0, 50, so over 0 up to 50. Next one is 1, 75, so over to 1 up to 75. Next one is 2, 100, so over to 2 up to 100. And the next one is 3, 125. Over to 3, up to 125. And again, I can tell that this is a linear relationship because it goes in a straight line. I also want to take a second and point out that in both of these examples, they are not proportional relationships. If I think back to chapter 2, to have a proportional relationship meant that my line had to go through 0, 0. In both of these circumstances, they do not go through 0, 0. These are not proportional relationships. They have an additional fee or something where they start at a place that is different than 0, 0. This one, for example, started at -5 before I started my line. This one started at 50 before I started my line. So I just wanted to point that out. We'll talk a little bit more about that in the next video.